All right, let's talk about determining an inverse function. All right, if you're given a function like this one right here, and you want to find the inverse of that function, well, you have to do a couple things. The first step is switch the x and the y. All right, wherever you see a y, put an x. Wherever you see an x, put a y. All right, switch the x and y. And the second step is solve for y. And so what I'm going to do here is I'm going to subtract 1. I'm going to get x minus 1 equals 2y. We'll divide by 2, and the answer is x minus 1 over 2. This is the inverse function of this. All right, 2 steps. Switch the x and the y, solve for y. That's how you find an inverse. All right? The next thing they're going to ask you to do in this section is to verify that 2 functions are actually inverses of each other. Okay? So here's 2 functions, f of x and g of x. So how can I prove that they are indeed inverses of each other? Well, we're going to do f of g of x. Okay, remember that means put g into f. And if we do that and we get x, then we're on the right path. So let's do that. Let's take the g of x, which is x minus 4, and let's put it into the x and the f of x. All right, so what this would be then, and we'd have x, oh, nope. I'm going to put x minus 4 into the place where the x was. So this was x plus 4, but now it's x minus 4 plus 4. Hey, what happens right here? The 4's cancel out and you get x. And so when you do f of g of x, you get x. That's good. Now you might think that that's enough to determine if they're inverses, but it's not. You also have to do g of f of x. That means you got to take f and put it into g. So let's take this one and put it in there. So it'll be an x plus 4 in for the x minus 4. Well, what happens with the 4's? They cancel out. And because both of these came out to equal x, we now know that the 2 functions are inverses of each other. Okay? So you have to do 2 things. You have to do f of g of x, and you have to do g of f of x to make sure, to be totally sure, that they are inverses of each other. All right? The last section wants you to do some graphing and then use the horizontal line test to determine if the inverse is a function. So let's see how that's going to work. Here's our function, 2x plus 1. It's really the same thing as y equals 2x plus 1. All right? That's in slope-intercept form, so we can graph this. I know that I've got a y-intercept of 1. I know I have a slope of 2 over 1, so that's up 2 over 1, and I know that this is my line. Okay? Now, do you remember how the vertical line test we used to use to determine if the equation was a function? Well, we could do that here too. Does this line pass the vertical line test? It does. A vertical line would only hit it 1 time. Now the horizontal line test tells you whether or not the inverse is a function. And it looks to me like no matter what horizontal line you draw, you will hit that line 1 time. And because of that, then you can say, yes, the inverse is a function. Also, this right here, f of negative 1 of x, f to the negative 1 of x, that's what we use to say inverse. That means the inverse of x. All right? Good luck.